All right, welcome to showing a limit using the epsilon delta definition. This is showing that the limit of x squared is, as x approaches 0, is 0. So this one, there's a lot of nice algebra that is involved and some very interesting arguments. So here's how the discovery phase will go. As always, start with this, plug in what you know. F of x is equal to x squared, and L, the limit is 0, so plug in those things, and this simplifies considerably because you don't have to subtract 0, just get rid of that. And then finally, think of what absolute value does to a positive number, right? Absolute value does nothing, and x squared is a positive number, so we can just drop that. Now, how do you solve an inequality involving a quadratic? It's easy to want to square root both sides, but that doesn't really make sense if you think about what's going to happen, and maybe the punchline you'll see in just a couple lines later why that might not quite make sense. So the thing to do in this situation is to always, I think the easiest thing to do anyway, is to study a different but related problem. And that different but related problem is just changing the inequality to an equal sign. But just keep in mind this is a different problem, and the solution to this problem ends up solving this problem. So what do you do in this problem? Epsilon is, remember, a positive number. If you want, imagine for now that epsilon is 9 or something, right? Then you square root both sides, and x would be plus or minus square root epsilon in general, or if you were thinking of 9, then you'd have a 3 here. Now, how does this relate to this solution for this problem relates to the original problem in that these two values that you get in the specific case, plus or minus 3, are the boundaries of the solution here. And how it works is that x would be bigger than negative square root epsilon, and simultaneously x would be smaller than root epsilon. And this is maybe the trickiest part of this whole thing. Actually, what you should do is think of what happens in the case x squared equals 9 here, or really you had x squared less than 9. And what you'd have to do to see how the inequalities go, and is this an and or an or, draw things on a number line, and you have to test points, right? So look between negative 3 and 3 in a sense, and then look outside of that range to a number like negative 4 and a number like positive 4. And using that specific example of epsilon as 9, you'll come to this conclusion. All right, so hopefully I hope that addresses why square rooting this thing right here isn't exactly what you want to do. If you did that, you just get this inequality here, but there's this other part, right, that is necessary, because if you only had this inequality, think geometrically, what you have is all numbers on the number line which are to the left of something, and you can just keep going. You can get really, really negative numbers. But look, if you look at this, a really, really negative number, once you square it, is positive, and that's got to be smaller than some fixed number epsilon. Okay, well anyway, you have these two, and you can combine this sort of in the usual way, or think of how this pulls apart into these two separate inequalities. And then from here, you can just make this look a little bit more like the form of the definition by putting in this minus 0, and just to recall that definition, this a matches up with this 0 here, and delta then should be root epsilon. So that's what we'll use. And on the next slide, the proof begins. So given a number epsilon bigger than 0, you let delta be square root epsilon. And start with this supposition as always. So start in this sort of scenario and take the fact that we're going to need, it's just going to be this one right here. That will always be the case actually whenever f is a continuous function. You won't have to deal with this part, right? This is for the non-continuous case, you actually have to deal with the weirdness that the value of the function is not equal to the limit. All right, so here, starting with this, plug in what we know. We have that a is 0 and that delta is square root of epsilon. And from here you can clean this up sort of in the same way we did in the previous slide. And now here, what you can do, we're not solving for x. We don't actually need to do that. Just notice that you actually have both of these two things are positive, right? So absolute value of x is a positive number, and square root of epsilon is a positive number. So since both of those are positive, you can actually square both sides of this inequality, and you'll get this statement right here. Now, since x squared is positive, this is the same as the absolute value of x squared, or maybe think of this backwards. Since x squared is positive, absolute valuing doesn't do anything, and it's okay to introduce this. The point of introducing it being that this is starting to look a little bit more like the formula that shows up in the precise definition. It's almost that. In fact, all you have to do is add in this minus 0. So we do that, and now you can replace x squared here with f of x. And now L with 0, or 0 with L, excuse me, and you have what you wanted to show. And so we're done.